Okay, so we're talking about limits here. And the first graph we're talking about is I'm just drawing a simple line. And we're talking this idea of what should the graph look like when x is 2. So go ahead, take a look at the graph. It's not a trick question at all. Not a trick question at all. But what should the graph look like when f of f when x is 2? Look at the graph. If this is 2 steps over, 1, 2, and 1. Would you guys be okay that the graph looks like f of 2 looks like 1? That's the y value. Right? And then, well, if I put f at 1.99, isn't that really close to 1, right? So as x gets closer to 2, as we're getting closer to 2, isn't the y value just getting closer to 1? How if I look at what is f at 2.01? Isn't that kind of also close to 1 if I'm going from the right side? So my point here, it seems kind of weird, and I'm kind of belaboring the point, but what does it look like? It looks like 1. When x is 2, the y value looks like 1. Everyone is kind of in agreement about that? And in math, this is the statement that we use. We say, hey, what does a function look like at 2? What is it at 2? If I could plug in 2, we should get 1. But what if I give you a problem that looks like this? 1, 2, 1. And this time, I'm going to draw a hole there. Remember we call this a hole? And I'm going to put the actual value a little higher than that. 1, 2, 1, 2. So this is my new function. We'll call this g of x. So my question is, what is g of 2? In the chat, can you guys tell me what g of 2 is? Type of the number. It's only a single number. It won't take you that much time. But please in the chat, what does g of 2 look like according to this picture? If you're afraid of getting it wrong, put it on private. But please, someone answer me. What does g of 2 look like? Or what is g of 2 in this scenario? You would say 1. And is it true? So someone took the risk and they said 1. Is it true that this graph is actually 1? But there's a hole there. So the actual value is this guy here. G of 2 is equal to 2, because that's where the position really is. The graph, even though it should have been 1, everything said it was going to look like 1. When I asked its neighbor to the left, it says, hey, yeah, the next value looks like it's going to be 1. When I asked the neighbor on the right, it said, no, it looks like 1 also. They both said it was going to be 1, but guess what? Were you there? It's like you saying, I'll be at my friend Mark's house. And when they call Mark's parents, hey, is my kid there? He said it was going to be at Mark's house. And guess what? You aren't there. So where are you? Who the hell knows? And that's what we're going to find out today. So the point here is that in math, we have specific ways of asking you questions. What is g of 2? What is it? Well, it is 2. We are at 2. But what should it have been? And here's our new type of notation. The limit as x approaches 2 of g of x is equal to 1. So this is our big takeaway today. This is our goal to understand what am I writing in this new type of notation. What is the limit? So this is right, the limit as x, wait, limit of g of x as x approaches 2 is 1. The limit of g of x as x approaches 2 is 1. And what I'm trying to describe is, hey, what's the y value? What is the y value as we get closer to x equals to 2? This is like the human speak. What does the y value look like as we get closer to x equals to 2? Now, coming back here, I want to make a big point here. I'm going to draw this really large now, the same exact graph that we just saw before. 1, 2, 1, 2. I drew a little hole here, drew a line. Oh, darn, I missed that one. So my question is this. What do I mean by as we approach? What limits work, the way they work in this simple fashion as, let me ask you on the left side. Here we're going to call this the left, and this we're going to call the right. So on the left side, as the x gets closer to 2, I want you guys to look at the y value. What does the y value look like it's going to become? It's becoming 0.5, 0.9, 0.99, 0.999. So are you guys okay that it's getting closer as it approaches? X approaches 2, the y value is getting closer to 1. Okay, that's examining from the left side. On the right side, as we get closer on the left side, also on the right side here, we start off at 1.1, no, 1.5, sorry, then 1.3, then I'm running out of space, 1.01, 1.0001, 1.000001. As we get closer to x equals to 2, we are getting closer to the y value of 1. So what does the graph look like? The left witness told me 1. The right witness told me 1. They both say 1. And that's what the idea of a limit is. The limit of, as x approaches 2 of g of x here, in this case, because this was g of x, the graph should have looked like 1. Now let me explain this in a different way now. Imagine if I'm looking at two people are on a construction job. Okay, two people are on a construction job. Okay. So I have one guy walking up this building. Okay. Pick a different color. So I have Mr. Red here, and he's walking up this building. Okay, he's going up. So as he gets closer to 2, what number do you think he's going to say it looks like? As he gets closer to 2, he sees 0.9, 0.99, 0.999. So what is he going to say it looks like? The whole looks like it's going to be at 1. He's going to yell out 1. It looks like 1 from this side. On the right side, we'll have a different construction worker coming down. Okay, be careful, construction worker, it's steep. And as he gets closer, he's going to call out his number on his radio. Okay, let's give them both radios. I see 1.1, 1.01, 1.001. Hey, you know what? On the right side, it looks like 1 also. So what happens is we examine what this should look like, not because what is actually there, because what is actually there in this graph here. What is f of g in this case? Whoops. What is, I used the wrong letter. What is g at 2? Looking at this after I took the dot away, this is actually undefined. Undefined means for us, there is no value. If you look here, since it's hollow, in this version here that I just changed, there's no value here. Okay. So the idea for a limit is what should it look like? Because in math, we had no way to describe what it should have been. Let's go ahead and give you guys another problem here. See how we can use limits to describe an answer which we didn't have an answer for before. Okay, the point is that we didn't have an answer, a way to describe this before. It's just, it looks like, I don't know. So let me give you this problem. Let's try another one. And here's a graph. And you can call this 3 and 3. Okay? So what's the limit? We'll call this f of x. Limit as x gets closer to 3 of f of x. So what do you think the graph should look like? Let's look on the left side. We're at 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. On the left side, would you guys be okay that it looks like it was going to be 3? On the right side, 3, 3, 3, 3, 3, 3, 3, 3, 3. We also say 3. So what does it look like it should have been? It looks like it should have been 3. The limits are a way for us to describe what happens at the holes. Before we would use the word hole, and we would actually have read the hole at 3, 3. We would actually say this. But in another way, we could say, what should it have been at 3? Well, it should have been 3. Let's give ourselves another problem. Okay, so you guys can see the graph doesn't exist. I'm gonna go ahead and put another value here. So what is, we'll call this f of x again. First question, what is f at 3? What's f at 3 here? What is the actual value? What takes the position? Where's the graph actually at? Would you guys be okay with the solid dot here? Up here, this is actually where the graph is at. So it took all of a sudden a bloop, a jump. That is 3. The actual value. And that's what we learned in Algebra 1. What is the actual value? What is the graph going to be? But we're learning something new today. It's a way to describe what should it have been. What's the limit as x approaches 3 of f of x? What should this have been? It should have been 2. Because that's what the graph looks like. See, everyone says, hey, I'm getting closer to 2. Hey, I'm getting closer to 2. A limit exists when both the left hand and the right hand side, both witnesses agree that they're the same number. That the left side says 2, the right side says 2. It looks like 2. But is it really 2? I don't care what it is. I care about what it looks like. Now let me give you one when the limit does not exist. Limit does not exist. Now, if I give you this example here, I'm going to give you guys a graph. One, two, three. Okay. So let me describe to you what we call one-sided limits. And one-sided limits means only from one direction. One direction. We have a left direction and a right direction. So let's look at the left one first. And then we'll look at the right. So the left direction, the limit, as x approaches, we'll call this number 3 again. 3. And take a look here. I didn't make a mistake here. I actually put a little negative sign on the top. So this little negative sign here denotes left. This denotes left. What does the graph look like when I'm coming from the left side? As I approach, now please take a look here. It's important x is getting closer to -3. Oh, not -3. 3, but from the left side. X is getting, see, X arrow, X is approaching, X is ninja, sneaking up on 3 from the left side. What does the graph look like? What's the y value as I approach 3 from the left side? It looks like 3. How do you guys feel about that? Is that okay for me to say it looks like 3? Only from the left side. We call this a one-sided limit because we're only looking from one side. Now take a look, which side am I looking at? I'm using a negative sign, and negative signs happen on the left side. What do you think? How would I denote the right side? Can you make that up in your head? How would I change this to be the right? Limit as x approaches 3 of f of x. How can I denote this to be a right? With a plus sign then. We use a negative for left, denotes right. So we're looking from the left side and the right side. And what's the right side look like? It looks like 1. So as I am approaching the graph from the right side, hey, what does it look like at 3? The right side says it looks like 1. So we have the left side saying 3, the right side saying 1. We have 2 witnesses. And do these 2 witnesses agree about what they see? One says 3, one says 1. Turns out, since the witnesses do not agree, we have no limit. What's the limit? As x approaches 3 of the function f of x, we have no limit. Why is it no limit? You can't tell me what it looks like. One person says 3, one person says 1. You're not in agreement. Limit does not exist. No limit. The limit does not exist. You guys remember that movie? The limit does not exist. The limit does not exist. And it's because both left and right side do not agree. Why do they have to agree? Because the idea of a limit is what should it look like? So what does it look like at 3? What does it look like at 3? Well, the left side says 3, the right side says 1. They're not in agreement. You can't tell me what it looks like. You tell me she's a blonde, but someone tells me she's a brunette. Someone tells me he's handsome. Some other person tells me he's ugly. Someone tells me he's rich. Someone else tells me he's poor. What does this person look like? Has a big nose, small nose. So let me tell you a story. And this is a story of 3 blind monks. Not 3 blind mice, 3 blind monks. So 3 blind monks are trying to describe this animal. This animal is an elephant. I want you guys to all imagine an elephant right now. Not the elephant in the room, but imagine an elephant. And I'm going to take one monk. One monk touches this elephant, okay? Because, you know, people who usually can't see, they use their hands to feel. So this blind monk describes the elephant as an elephant is like a rope. All right. Okay, elephant's like a rope. Thank you. The next blind monk approaches the elephant and touches the elephant and says, this elephant is like a watering hose, like a garden hose. Okay. This is a weird description, right? Then the third blind monk comes up and touches the elephant and says, this elephant is like a tree. One says a garden hose, one says a rope, and one says a tree. Are any of them wrong? Well, guess what? They're looking at different parts of it. One who said the rope was probably touching the tail. One who said the garden hose was touching the nose. And the one who probably said it was a trunk was touching the foot, right? And that's the idea of this limit. We can look at different parts of it, but can they agree? Do they have an agreement what an elephant looks like? Do they have a limit? Answer is no. So for us, that's what we're studying today. We're using this word limit to say, sure, I get it. The actual, what is the actual answer here? What is f at 3? The actual answer is 2. But the idea of limits, we can still mathematically talk about what should this value be. On the left side, it should look like 3. Got it. On the right side, it should look like 1. Is there an overall value that they all agree on? Nope, there's no limit. But what is the actual value? The actual value is 2. And this is what the new vocabulary we're using today to talk about how to use limits to describe numbers in math. Okay, so here's an example of the IXL problems you guys are going to see. The question is find the limit of f of x. Use the graph of f of x to find the limit. Now, please look at the notation they wrote. They wrote here the limit as x gets closer to 9. So we're going to try to get close to 9. We're going to creep up to 9. So let's find 9. Do you guys all see 9 is right here? 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 9 right here. So what's the y value? On the left side, it looks like -2. On the right side, it looks like -2. Is the left and right side in agreement? Yes, but take a look. It looks like -2. What is the actual value though? The actual value is -5 here. But that's not the question. The question isn't what is the actual value. The question, what is the limit? What does it look like? And hopefully you can notice that it looks like -2. Now limits when it comes to graphing, it's that easy. Just tell me what it looks like. For this problem, let's read the question first. What is the limit as x approaches? So what's the y value as x gets closer to 1? Let's take a look here. The y value as x gets closer to 1. As x is getting closer to 1, the y value looks like 8. Again, not to be mistaken for 4. 4 is what it is. 8 is what it looks like. Let's write the difference. The limit as x approaches 1 of f of x, what does it look like versus what is the actual value at 1? The actual value at 1 is 4. What does it look like? It looks like 8. Let's do one more together. Okay, what's the question first? What does the graph look like when x is 5? Let's take a look at the graph over here. As we get closer to 5, as I'm walking through the park one day, as I get close to 5, see 5 is right here. So as I get closer to 5, the y value is shrinking to 3. It looked close to 3, right? We're not actually on 3. On the right side, as we get closer to x is 5, see x is 5, we're walking this way. Closer to 5 on the right side, it looks like we're getting closer to 3. They're totally in agreement here. So the limit is 3. It looks like 3 from both sides. We are in agreement. Okay, so let's go ahead and take a look at some other practice problems that we have. You guys are going to be working on 3 of them. Next one is find the one-sided limit. So take a look here. We look at the graph, and is there a limit or is there not a limit at 2? Do we have a limit or do we not have a limit at 2? The left side says 3 and the right side says 6. Do they have agreement? Do they have any clue what the elephant looks like? Nope. So what is the question here? The question is specifically the limit as x approaches 2. Now, naturally, when I see plus and minus, would you say plus is right or plus is left? Would plus be on the right side of a number line or would plus be on the left side of a number line? The plus is on the right side. So we're thinking it's coming from the right side. As I get close, not as I run away. Okay, I'm not running away. I'm running to 2. I'm running to 2. To 2. So as this line gets closer and closer to 2 on the right side, what does the y value look like? It looks like 6. Okay. How would I write it from the left? Well, let's go ahead and write the 2 possibilities. The limit as x approaches 2 from the right side of f of x, we said that was going to be 6, right? As we get closer, we end up with 6. But the limit as x approaches 2 from the left side, we are actually getting closer to 3. And no, these do not agree. They do not agree. So we have no limit because both witnesses have to be in consensus. Okay, let's look at one more. The last one you guys are going to do today is determining if the limit exists. So I want you guys to take a look at this. Does the limit at 0 exist? I want you guys to really look at the basics. Does the left and right side agree? Like, no joke. Does the left side says -5 and the right side says -5? They both look like -5. I want you guys to be able to say they both left and right side agree as -5. So if they both are in agreement to the witness, yep, the value is going to be -5. Now let's look at for a problem that isn't. So take a look here. Does the limit exist at -8? So at -8, the left side says, as we get closer to the graph, it looks like it's going to be 8. So as I'm getting closer to here's -8. That's my timeline, -8. So as I'm approaching from the left side, this -8 looks like it's going to become 8. But on the right side, as I get closer, does that look like I'm getting closer to 8? No, this y value is actually 4. So can you tell me that the left and right side are in agreement? Do they have the same limit? The answer is nope, they do not have the same limit. So our answer here is that no, the limit does not exist because the left side and right side do not agree. I cannot tell you what it looks like when they both have no clue what they're even talking about. One says 8, one says 4. Imagine if your family, your dad said Chinese and your mom said Mexican food. What are you eating? Probably some chips, right? Probably end up being chips. Okay, so that's the idea of limits. Go ahead and practice that. It won't take you that long, and that's it.